Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about giant movements about origin for multiple random variables. In that giant movement about origin for multiple random variables, we have the second order movements are M20, M02, M11 are the second order movements. And out of those three second order movements, one of the second order movement is M11. Okay, so that second order moment M11 is the correlation of the random variables x and y, and it is denoted as r suffix xy. So now here in this video I am going to discuss about correlation definition and some important properties of the correlation of the random variables x and y. And the definition of the correlation between two random variables is: consider two random variables capital X and capital Y. The second order joint moment M11 is called the correlation of the random variables capital X and capital Y, and it is denoted by R suffix xy. So mathematically, and it is given by correlation between two random variables, R suffix xy is equal to M11 is equal to expectation of xy. So which is equal to integral minus infinity to infinity, integral minus infinity to infinity, xy into fxy of x comma y dx dy. So the correlation between two random variables is denoted by symbolically r suffix xy or m suffix 11 or expectation of xy. So this is the mathematical definition of the correlation between two random variables x and y. Next we are going to discuss about properties of correlation. So the first property is: if two random variables capital X and capital Y are statistically independent, then the random variables x and y are said to be uncorrelated. So that is r suffix xy is equal to expectation of xy is equal to expectation of x into expectation of y. The proof of this property is: so consider two random variables capital X and capital Y are the two random variables. With two random variables, joint probability density function is fxy of x comma y, and marginal density function of the random variables x and y are fx of x and fy of y. If capital X and capital Y are two statistically independent random variable, the condition of the statistically independent random variable condition of the giant probability density function condition is fxy of x comma y is equal fx of x into fy of y. So this is the definition of the correlation between two random variables. So in this definition, applying the giant probability density function statistically independent random variable condition, that is fxy of x comma y is equal to fx of x into fy of y, applying that condition into here. So the RHS term can be arranged as our convenient: integral minus infinity to infinity x into fx of x dx, integral minus infinity to infinity y into fy of y dy. So on RHS side, all are the product terms. So these RHS terms can be rearranged as integral minus infinity to infinity x into fx of x dx, integral minus infinity to infinity y into fy of y dy. So using definition of expected value of the random variable, the first integral term is expected value of the random variable x definition, and the second integral term is expected value of the random variable y definition. So that is expectation of x into expectation of y, or xy is equal to expectation of x into expectation of y. That is the first property. And the second property is: if the random variables capital X and capital Y are orthogonal to each other, then their correlation is 0. That is R suffix xy is equal to 0. So from the previous property, okay, the random variables x and y are two random variables with their giant density function is fxy of x comma y, and its marginal density functions are fx of x and fy of y. If capital X and capital Y are
capital X and capital Y are said to be two orthogonal random variables, then their joint density function is 0. Fxy of x comma is equal to 0. The random variables x and y are orthogonal random variables. The value of the joint probability density function is equal to 0. That is fxy of x comma y is equal to 0. Applying this condition into correlation between two random variables expression, substitute this condition into here. The expectation of xy is equal to 0. So that is the second property of the correlation between two random variables. So these are some important properties of the correlation between the random variables x and y.